let's see what it says. Okay. So those, because it's a vector, we need coordinate, right? So you please follow my reasoning. You don't have to copy my reasoning, but I would like you to understand how I get the solution by applying and by following the reasoning, right? So I say I have coordinate x plus and y plus I have coordinate z plus, because it is very general. So let's see what's happened in x direction. Okay, I can see MA V0 is equal to MA VA. Therefore, MA VA equal to V0. Is it correct? Why? Okay, there is another MBVB, because you have to look at everything in x coordinate. Don't confuse by any picture. So I have to write over here MBVB. One equation. Minus, okay. Because I selected this coordinate as a positive in this direction, and I assume that the velocity of B in this direction. You can assume this, but the law will provide you VB would be negative. So don't worry. You can assume it, the direction. And the law will correct your assumed direction. Okay? That's important. You just follow the law. You don't have to puzzled by something which you do not know. So I'm emphasizing again, this is dynamics course. You select the rule and you follow the sign convention of coordinate, and then, as you know, number of unknowns and number of equation type things. Okay, what about in y direction? There is nothing, right? So it's trivial. What about in z direction? What about the z direction? Z direction, this says linear momentum has to be conserved. What about the angular momentum? Angular momentum. Angular momentum as state 1. Okay. I have to take angular momentum. That means angular momentum is angular momentum is simply taking a moment about linear momentum vector. That's angular momentum. Okay, it's not difficult one. You just, because this is a vector expression, if you take a moment with respect to something that is angular momentum, then this one has to be measured with respect to coordinate, right? So not only the direction of coordinate is important, but also the origin of the coordinate is important, right? So there are two ways. You may select the coordinate with respect to center of mass, Okay, or you may select a coordinate from with respect to mass B. Which one you would like to use? Doesn't matter actually, right? Okay, doesn't matter, but which one you would like to use in this case? 형근이? Which one you would like to use? I will just follow your selection. I will not argue whether what you choose is correct or not. Okay, this one. This one. I would say mass center rather than weight center. Okay, mass center would be appropriate. I prefer to use symbol G to represent the center of mass, and we do not know G, right? Where is it? Okay, G is a mass center, so that I can write m bar, that is total mass, and Lg is the distance of center of mass. That has to be ma La plus mb lb. What is La in this case? It's not Los Angeles, La. La is what? Is measured with respect to what? From here, so that is La. Because we are using this coordinate, that should be La. This should be Lb. What is then L? 0? Okay, this has to be 0 if I use the coordinate I select. Okay, he said yes. Okay, I will follow his reasoning. So that means MA LA plus MB LB should be 0. Okay. So this equation actually says the ratio between LA, LB has to be inversely proportional to the mass. Does it make sense? If there is a large mass, the center of mass has to go upward. If that one is a small mass, center of mass go downward. Does it make sense? Minus. Wow, minus. Okay. So that should be minus because I am measuring from this point, right? So that should be plus. And that has to be minus and minus. So that's good. That's good. So we do know what it means by G and what it means by LA, LB. Okay. So let's take angular momentum with respect to center of mass. So I'm taking angular momentum. What is this? LA, MA, V0. There is nothing. So 0. That has to be equal to LA, MA, VA, and then LB, MB, VV minus, because LB is minus. Is it correct? Why? Why you shake your head? Why? Okay, he said, sorry, this has to be plus. Okay, this one has moment in this direction, this one has a moment that direction, so That has to be plus. And if somebody say, oh, no, he noted that is minus LB. Therefore, we have to multiply minus LB. What's wrong with that?
VB가 마이너스 VB.
Okay. VV in that, if you use that sign convention, then you have to use VV is minus. Okay, so that is very consistent. Mathematically correct, physical intuition follows mathematical derivation, right? So everything looks fine. And let's count number of equations. 2. Number of unknowns. 2. So we are happy. Okay, we are happy. So you can solve it. Okay?